T-test is a very simple bivariate analysis, and it's for situation that independent variable is a dichotomous variable, is a categorical with only two levels. Dichotomous variable, like gender, male and female, like type of tourist, for example, domestic or international, right? Size of company, small and big. So when we have independent variable is a categorical variable only with two levels, or it's dichotomous variable, and dependent variable is continuous variable. So for hypothesis testing, we need to use t-test when we want to compare two groups, when we want to compare a level of something for two different groups, like satisfaction for male and female, right? But under t-test, we have different types of t-test based on your hypothesis, right? Sometimes you want to compare level of something, for example, mathematic score of student with the average of school average, right? So we have school average for mathematics, and we want to compare we want to compare one class with average of school. For this case, we use a single sample t-test or one sample t-test. So for a simple sample t-test or one sample t-test, we compare data from one variable with the specific value. So the hypothesis is, for example, the average of mathematics score of this class is equals to average of school. For example, average of school is 3.2, right? So we want to see difference between this class for mathematics score and the average of school. So we want to compare to see, is there any significant difference between math score of this class and average of the school or not? So for this one sample t-test or single sample t-test, hypothesis is, for this case, for example, null hypothesis is there is not any significant difference between score of this class A, and average of school score, right? So this is null hypothesis. Null hypothesis is, always is non-existence of difference between two groups. And what about alternative hypothesis? Alternative hypothesis is there is significant difference between math score of this class and the average of school. So here you can see null hypothesis is mu x minus mu p. Mu p is, for example, average of school, is a specific value. So this is the first type of t-test, when we want to compare and when we hypothesize difference between our data set and specific value. Second type of, okay, we'll back to this one. Second type of t-test is pair sample t-test. Pair sample t-test is for some situation that we compare data from one group, but in two different situations. So our sample, our respondent are same, but we collected data in two different situations, and we want to compare data for these two situations. For example, we have 30 students in the class, and we want to compare level of stress. We design an experiment. We ask a student to do some yoga exercise, right? Measure level of stress before yoga exercise and after yoga exercise, and compare these two situations for same group of people. Compare level of stress for situation 1 and situation 2. So third sample t-test is for some time that we most of time use for experiment. So we want to see effectiveness of an experiment. So we collect data before experiment and we collect data after experiment for same group and compare. So this is for paired sample t-test. A test is paired sample t-test. What's the null hypothesis and alternative hypothesis for this one? Null hypothesis is there is not any significant difference between level of stress in before and after yoga exercise. And alternative hypothesis, there is significant difference between level of stress before and after yoga exercise. So this is for this type of hypothesis for paired sample. Another t-test is independent samples t-test. Independent sample t-test is for study or situation that we want to compare. We want to compare something between two different groups. We want to compare level of stress between boys and girls, right? We want to compare between male and female. We want to compare satisfaction between male and female, local and international tourists, right? So when we have two different groups and want to compare social phenomena, want to compare a variable between these two groups, we have to use independent sample t-test. So for this one, null hypothesis is there is not significant difference between level of satisfaction between male and female. And alternative hypothesis, there is significant difference between satisfaction of male and female, right? So so these are the three different types of t-tests that we can apply based on our hypothesis. And we can run analysis and compare results and see what's the significance between these two groups for some variable. Okay, this is the formula to calculate the significance of difference for single sample t-test. But just to know, this is the formula. You don't need to use this formula because SPSS or software can automatically calculate this significance level. This is t-value, and p-value is calculated based on this t-value. So based on this t and p-value, you can interpret the result and see there is significant difference or not. This value is Cohen D value. This is effect size. It's good when we apply an analysis technique addition to significance of analysis technique and significance of result, we apply this effect size. Effect size actually show power of our analysis and how reliable is our result. Because this effect size can, because actually sometimes in analysis can happen error type 1 or error type 2. Error type 1 is sometimes that we reject null hypothesis, but actually null hypothesis is true and we should not reject it. And error type 2 is sometimes we reject alternative hypothesis, but actually alternative hypothesis is true and we should not reject it, right? So to avoid this type of problem, especially error type 2, because you remember always we report alternative hypothesis. Actually, we assess null hypothesis. And when we reject null hypothesis, we conclude supporting of alternative hypothesis. But we report alternative hypothesis. So to avoid this mistake, it's good to report effect size. But effect size should, unfortunately, should not be calculated automatically by software. So you need to do manually. This is formula for single sample t-test. And this is the interpretation of effect size. Effect size, if it's lower than 0.2 is not acceptable, between 0.2 and 0.5 is small, higher than 0.5 and lower than 0.8 is medium, and higher than 0.8 is high. For t-test, effect size for t-test. We have different formulas for different analysis techniques. For paired sample t-test, the formula is similar to single sample t-test, is T equals mu1 minus mu2 divided to standard deviation. But standard deviation of difference between two groups. Difference between two groups. And this is the formula for calculating effect size for independent sample t-test. Independent sample t-test. So the software gives you significance of this test, but if you want to calculate effect size should be calculated manually. So this is three different types of t-test. One sample or single sample t-test, paired sample, and the independent sample t-test. Created community attachment, right? Community attachment. So we have now community attachment. For example, we know the community attachment of average community attachment of a community. Here is not very meaningful, but just we assume. Average community attachment of a community, a specific community, between 1 to 5 is 4, right? So we want to compare and see the community attachment of our sample, our respondent. We have a few hundred respondents and we collected data for this few hundred respondents. We want to see, is there any significant difference between our sample and community, average of community or not? And we want to see the community attachment of our sample is higher or stronger and weaker than average of community, average community attachment of this specific community. So we want to compare. So if this is our object, this is our hypothesis, we have to use single sample t-test, right? Because we want to compare with specific value. We need to go to analyze, compare means. For all tests, for all t-tests, we have to use compare mean, right? Okay, compare mean. One sample t-test, because we want to compare with a specific value. One sample t-test. So the variable that we want to test, we transfer to this box. This white box here, test variable. Here is variable is community attachment, right?
Yes.
We transfer community attachment to this box. And what's test value? The average of community is 4. So the average of community is 4. So we put 4 here, right? In option, okay. Here in option, you have list-wise or case-wise or pair-wise for missing value. If already you didn't solve missing value, you can select one of these two methods here to deal with your missing value. Okay, so continue. There is another option here, bootstrap, right? Now we escape from this bootstrap, but I will explain what's the meaning of this bootstrap. Okay, so click on OK. Here, this is two-tailed, right? This test is two-tailed. And the t-value now is 5.154. So it's higher than 1.96. So the p-value is lower than 0.05. And the CI, both are lower and upper are positive. So the results support our hypothesis. So there is significant difference between community attachment of our sample and average of community based on this result, right? Mean difference is 0.1677. This is the difference between average or mean of our sample and specific value. This is positive, means the average of community attachment from our sample is higher than average of community. Average of community, right? So this is for pair sample t-test, we have to compare data for two groups. For one group, but for two situations, two different conditions, after and before experiment, for example, right? Here, we don't have data for this one, but I just want to show how we can perform. So we can use, okay, I have two community attachment. I have two variable called community attachment. Okay, one, for example, one is before and another one is after an experiment. So we did something and we want to see, is there any significant difference between community attachment before this experiment and after, right? So again, for this one, we need to go to analyze, compare mean, paired sample t-test. Here we have two variable, community attachment, variable 1, but it's first pair, and community attachment 2, option, just for missing value, bootstrap. Okay, now it's good to explain bootstrap. Bootstrap, actually for t-test, for different types of t-test, one sample, paired sample, and independent, we need normality. So our data should be normal to be able to use these t-tests. Actually, these t-tests are parametric t-tests. So normality is a requirement. Before we check normality of our data, based on skewness and cortices or based on Shapiro-Wild criteria. So based on some method, we check the normality. If skewness and cortices is between -3 to 3, so it means our data is almost normal. So we can continue with parametric test. But if our data is not normal, cortices and skewness is very high, or based on Shapiro-Wild test, we find our data is not normal. So we need to apply non-parametric test. These tests, these t-tests are all parametric. But later I will show you some non-parametric t-test. But if we want to stick to this type of t-test with non-normal data, we have to use bootstrapping. Bootstrapping is a resampling method, actually resampling method. And software based on your sample create much more resample and perform your test based on these resamples. These different resamples, when we apply these different resamples, actually our data will transfer to normal data. Because we have one data set. When we apply bootstrapping, for example, if I click on bootstrapping, perform bootstrapping, here ask you about number of samples. Here, this number is number of resample, generated resample. For example, if you have 300 cases, this is one sample, one data set. Here is 1,000. So the software create 1,000 data set and perform analysis based on these 1,000 data set. So using resampling and bootstrapping, still we can apply parametric test for non-normal data, but using bootstrapping. Recent version of SPSS, I'm not sure about the SPSS that you use. You can check that your SPSS has this feature or not. But the recent SPSS, I think after, if I'm not mistaken, I'm not sure, but I think after 24, version 24, this bootstrapping included in software. So using this bootstrapping, you can still perform all analysis techniques that need normality, but your data is not normal. Still, you can use these analysis techniques, but using this bootstrapping. So if we click on continue and okay, so here we can see the result. The table is exactly similar to one sample t-test. So here you can see mean difference, standard deviation, t-value, and p-value. T-value is 2.24 for difference between these two community attachments before and after our experiment, right? So the t-value is 2.24. So it's higher than 1.96. And our hypothesis is two-tail hypothesis. Because just we hypothesize there is significant difference between community attachment before this experiment and after this experiment, before this training and after this training, before this event and after this event, right? So this is our hypothesis here. So a hypothesis is two-tail. T-value is 2.24, so higher than 1.96. T-value is 0.026, so it's lower than 0.05. And confidence interval, both are positive, lower level and upper level. Means 0 is not within this range. So based on t-value, p-value, and confidence interval, we can confirm significant difference between community attachment of resident, community attachment of respondent, before and after specific experiment or event, right? So this is interpretation for paired sample t-test. So interpretation and the table is almost similar with one sample or single sample t-test. For independent sample is a bit different. Okay, for independent sample t-test, we want to compare between two independent groups, right? Male and female. So we want to compare community attachment between male and female, right? So we have two different groups. Again, to analyze, compare, but here independent sample t-test. So click on independent sample. Here we have two boxes. One is for our variable. Our variable is community attachment, so transfer community attachment. But here we need grouping variable. We have another variable here, independent variable. This variable is a dichotomous variable with two groups, right? Here, yes, variable is gender, including male and female. So we transfer gender here. But we need to define groups. One, our groups are 1 and 2. 1 is for male and 2 is for female, right? Again, here option and bootstrapping. If you want to use bootstrapping, you need to click on perform bootstrapping. So click on OK. Table here is a bit different with previous tables. So this is a result, right? For result, like previous test, first one is some descriptive for each group, group 1 and group 2. Number of respondents for group 1 for male, and for female is 209 for male and 200 for female. And this is the mean value for each one, standard deviation, standard error, right? But interpretation is here. For this table, we can interpret result of test. But here we have two different rows. Two different rows. In one sample t-test and pair sample, only we have one row. But here we have two. What is this two? For independent sample t-test, we have one more result. We have result of Leven's t-test. Leven's t-test tests actually variance of two different groups. Test equal variance of two different groups. If result of this F test and significance of this F test. This is p-value based on this F value. If this p-value for Leven's test is higher than 0.05, higher than 0.05 means the variance of these two groups are equal. The variance of these two groups are equal or are not significantly different. If this p-value is higher than 0.05. Okay, so based on this value, we need to interpret one of these rows. Here, the p-value is higher than 0.05, means variance of these two groups are equal, right? So we need to interpret which one? Equal variance assumed, equal variance not assumed. So we need to interpret result from first row. If this value, this significant, this p-value is lower than 0.05, we need to interpret this row and assume that variances of these two groups are not equal, right? So for this case, we need to interpret first row. Okay, again, first row. We have the t-value. T-value is 0.653 and p-value is 0.514. So what does it mean? Anybody can answer? Anybody can interpret the result of first row for this hypothesis testing?
It's not significant. Therefore, there is no significant difference between the gender.
Exactly. Exactly. So p-value is higher than 0.05 and t is lower than 1.96. Means the difference between male and female for community attachment is not significant, right? So alternative hypothesis cannot be supported by this result. Here also, if you look at confidence interval, lower and upper levels, lower level is negative, upper level is positive. So 0 now falls within this range. 0 is between lower and upper level, right? Because lower level is negative and upper level is positive. So based on confidence interval, also we can confirm that these hypotheses cannot be supported. And this test, the result of this test is not significant for difference between male and female. So there is not any significant difference between male and female for community attachment. For first assignment, you need to report the result and interpret. For example, here, if we get significant difference between male and female, right? And 1 is male and 2 is female. Here, mean difference is positive. But instead of 0.04, for example, we get 0.42, right? And positive. And result is significant. Means the difference between community attachment of male and female are significant and positive. Means community attachment of male is higher than community attachment of female, right? Community attachment of male is higher than community attachment of female. So this mean difference is the difference between group 1 and group 2. So we can interpret the result based on these values, right?